In class, we showed you how you can take a cone and build a net for it. When you unravel or unfold that net, you end up with two parts. The two parts are the circle, which is the base, and this lateral surface area, which almost appears to be a sector, a large sector of a circle. Okay? And so what we're going to develop is, we're going to develop the surface area of a cone formula, and we're going to find that it's the area of the base, which we already know is pi r squared. And then we're going to find out how to do the lateral surface area, this area right here. Okay, so if we draw a lateral surface area of a given cone, we don't have a formula for this shape. But if I divide it up into other shapes, it almost looks like these shapes are something that we know. It looks very close to a triangle. Now some of you will say, no, this is kind of curved, and I will agree that for right now, the base of the triangle does have curves. But let's just suppose them to be triangles, and let's say that the base of this one is b sub 1, the length of the base of this one is b sub 2, the length of this one is b sub 3, b sub 4, all the way over to b sub n. And we could divide it into 10, 100, 1,000, or infinity. So we remember our area formula for a triangle is 1/2 base times height. The base here is b1, so to find the area of this triangle, we'll go 1/2 b sub 1. The h, this distance, is what on this? Notice that this right here, as we unfold it, is really this distance here. Now, some people might call that the height of the cone, but the height actually goes from the center to the tip. This is called, very ingeniously, the slant height. Slanted, it's height, but it's the slant height, not the altitude of the cone. So this right here, this h, is the slant height, and typically they will use the letter L for that. Okay? That is this distance from the tip of the cone to an edge of the base of the cone. Okay? So the area of this first triangle would be this formula. 1/2 base times height, which is our slant height. Now the area of the next one would be 1/2 b sub 2 times L to get the area of the next triangle. Area of the next one, 1/2 b sub 3 times L plus dot, 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 all the way over to 1/2 b sub n times the height, or slant height. This, adding up all of these triangles all the way across, will give us the total lateral surface area of the cone. But this isn't too helpful in the method that we've got it here. So let's do a little algebra with it. Do you see any common factors? Something we could take out of each of the terms? Yes, you're right. We could take out a 1/2 out of each and a slant height out of each. What's left over from this first one after we take that out? You're right, b sub 1. After we take 1/2 L out of here, we've got b sub 2 plus b sub 3 plus dot, dot, dot over all the way to b sub n. Okay? Now, if you'll take a look at our net again, this entire distance from here to here is what? You're right, it's simply the circumference of the base of this circle. So if this is the circumference, I'm going to replace that big expression right here, all of these added together with circumference. But we know circumference from our formula list is just 2 pi r or pi d, so I'm going to go 1/2 L, and in place of c, I'm going to put 2 pi r, which is my circumference. Now I'm going to do a little bit of simplifying. 1/2 times 2 is 1. 1 times anything is itself, and I end up with pi r L. Pi r L, pi times radius times slant height is the formula for the lateral surface area. So over here we'll put pi times the radius of the base of the cone times the slant height of the cone. And there is the surface area formula for a cone. Now, just to help some of you who have an imagination, I'm going to go one more step here. Let's imagine that I have this cone. Instead of having it out of hard plastic like this, let's imagine it being latex like a balloon. So that I could grab this, and let's say that the bottom is rigid, but the top is made out of latex. So that I could grab this and make it go higher, lower, higher, and lower. Can you see in your imagination, can you see this cone going higher and lower? Okay, I have the same cone. Use your imagination. It's got a rigid base. The base is staying the same. I am stretching, and now we've got a really, really tall, skinny cone. Now we've got really, really short. Now, imagine with me as the cone collapses, what is happening to the L? What is happening to the L just at the point, I've got this circle in my hand, the base, just as the cone collapses, the slant height becomes what? You're right, it becomes the radius. And so, if we were to let this L get very, 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 very short, it would collapse. When it collapsed into, became an R, we would have the lateral surface area of that cone being pi r, and L would become r, pi r r, which is pi r squared. So the formula even works for a cone that's collapsed. You just have the area of the circle there. Hopefully that might help you remember this pi r L as well as this little diagram. Thank you very much.